Hi everyone, today we're going to be talking about lesson 7.2, which is the natural base e. E is a constant in math similar to pi. It's an irrational number and it's called Euler's number. And e is approximately equal to 2.71828. We use this number when we do compound interest, if the interest is compounded continuously, and it also appears in the natural base exponential function, which we will see today. So in order to get e on your calculator, kind of like you put pi into your calculator so that the calculator will hold all of the digits of it, on the calculator you want to type the second key, the blue key, and then the division symbol, and that will give you an e, and it will treat it just like pi. If you're in Desmos, then just type a lowercase e and it automatically sees it as Euler's number, 2.71828, and this actually goes on and on forever. Let's talk about how to deal with e in expressions, and e can have an exponent on it similar to a variable. So because it can have exponents similar to variables can, we use the same types of rules that we had for exponents on variables. In other words, if we are multiplying two things that have e as a base raised to an exponent together, our exponents are going to add. So e to the third times e to the sixth would be e to the ninth, 3 plus 6. If we're dividing, then our exponents will subtract, just like if e had been any other variable like an x. We'll have 16 over 4 is 4. E to the 5 divided by e to the fourth. Well, 5 minus 4 is 1, so that just gives me a 4e. We can have negative exponents on e. And remember that when you have a power raised to a power, your exponents will multiply. So 3 to the second power will be a 9. Our coefficients do get powers taken. And e will be to the negative 8x power, negative 4x times 2. However, remember that we can't leave a negative exponent in a simplified expression. We need to fix it. So this is going to become 9 divided by e to the positive 8x power. Remember that negative exponent means take the reciprocal of the base, but make the exponent positive. Finally, if we are taking a root, we again kind of treat it like an exponent on a variable, and we will simply divide the index into the exponent. First, we'll deal with our coefficient. The fourth root of 16 is 2, because 2 times 2 times 2 times 2 gives me 16. And now we need to say how many e's we can take out, just like we would say how many x's. Well, this time 4 will divide into 24x 6x times, and that goes evenly. We don't have any left over, so we'll have 2e to the 6x.